course, we can also do numerical derivatives with the chain rule, just like we did with product and quotient rule. So this is a recognition of the fact that you are dealing with a composite function. You have an inside piece, g of x, and an outside piece, f. You also are given lots of information about f and g, but you don't know the actual functions, so this is a numerical derivative. First thing we would want to do is apply the rule using the variable. This is how you're going to see the chain rule applied a lot. The derivative of the outside, f prime, leave the inside, g of x, times the derivative of the inside, which is g prime of x. You need to recognize this as the chain rule. Now let's do h prime of 3. So everywhere I see an x, I'm going to apply a 3. So f prime of, excuse me, g of 3 times g prime of 3. This of situation very much matters. This is not f prime times g of 3. This is f prime of g of 3, which means there's an inside piece that is applying to the f, or to the f prime in this case. So f prime of g of 3 was given to me. G of 3 is 4 times, and then g prime of 3 was also given to me, negative 5. Notice how everything is linked, right? So I've got my h prime of 3 labeled. Of course, I'm always going to label. I have equal signs. I'm connecting things with equal signs, always. F prime of 4 was 8. So this whole thing gets replaced with 8 times negative 5. So my numerical derivative is negative 40. That is representing the instant rate of change, the slope of the tangent line. Okay, however you want to think about that. But that is the instant rate of change when x is 3 for this given function, as long as I have these pieces of information. No, I didn't use all the information. Okay, I just used a few pieces of it. But that is part of recognizing how to use the chain rule.